Okay, well, thanks for coming. It's not as big a group as we hoped, but you never know. So, today I'm going to talk about ERP for a year, and is it your fault? Is it your fault? But, okay, this is a brief introduction. I'm Lance Goddard. I've had a long career in software, so I think I first programmed my first computer in 1963, probably, which was a IBM 7040. So discrete transistors, no integrated circuits, right? So we took card punch, they've gone a long way back, right? And then I started my PhD in computability theory, and so I've had a very varied background, having done mathematics PhD, aerospace programming, enterprise programming, operating system programming, language programming, running a company. I worked on Microsoft Office programs, wrote some Excel, stuff for Excel and Microsoft Word. So we had a company in the 90s that I sold. So it's been a lot of experience. And I'm kind of one of these people who can't stay away from programming. And so I started out programming in Fortran 4 and something on a set of 7040, and now these days it's all Java on cloud computers and just, all the regular latest stuff. And so it's been interesting being around for the whole thing. Now, let's talk about ERP implementation disasters. There's been lots of reports, right? Everybody seems to like doing ERP reports, tracking them, surveying them, whatever. 50% of ERP systems either fail or really don't make the grade in some way, okay? The average time to implement an ERP system, I think in 2016, is 16 to 20 months, I'm not sure. It's around there, it keeps popping around in the surveys. We've got to remember these surveys are kind of noisy. They're getting self-reported data. So it's hard, so they're not that accurate, but they're probably, they indicate what's going on. I think everyone in enterprise computing knows it's a problem. We have things in the press all the time about systems going down, failing, costing a lot of money. So, without going through a whole litany of failed systems, which I could sit here for like the rest of the week, right, listing them. This is one that's kind of interesting because it's in the news right now, the Phoenix system of the Canadian government, right? It's been in the national news, if you haven't seen it. The unions conducting rallies with, signs, protesting. We have about 300,000, this is federal, we have about 300,000 civil servants in Canada paid by this system. It's, which they just recently upgraded to this Phoenix system, which is done by IBM based on PeopleSoft. And it's been a total unmitigated failure. They're having, almost riots. Some people haven't been paid for a year. People haven't been cashing RSPs to make ends meet. People are on pensions, like old people are not getting their checks. Now I picked on this one. Some people will have to drop out of university because they can't pay their fees. I mean, it's kind of shocking. And yet, the reason I choose it is because it's very iconic. With payroll, when you get the person's check at the end of the month, there's only one correct number, right? Any other number is wrong. There's a number of dollars you owe that person at the end of the month, and everything else is a wrong number. Well, they can't get that number right. They've got 80,000 people they paid the wrong amount to or not paid at all, right? And they keep on, So this is the kind of problem you get. Now, I thought this was really the most egregious system that I could find because it's really front and center. A lot of the time when we read in the paper about ERP failure, it's kind of hard to know what's going on. There was one in BC here recently with the Ministry of Human Resources and people in care and that kind of thing. But you never know when you read the stories. Is it because they like the old system and they don't like the new system, they don't want change, so they're complaining? It's kind of hard to read between the lines. But this one, it's wrong because they're not getting paid. It's simple, right? I mean, it's wrong. Okay. Now, as I said, I thought that was pretty bad. I just found out, if you look at Ars Technica, There's a system in the States called Odyssey, which is used in the US court system, and actually innocent people are going to jail from that system. So, you know, not getting paid is bad enough. However, going to jail when you didn't do anything is probably a lot worse. Yeah, I knew. Now, this payroll system's had a bad history. The Queensland government in Australia sued IBM for $800 million US because of a failure. But IBM is way better writing contracts than they are writing software. So they lost that case because the contract was kind of ironclad. They had no out. It failed in Palm Beach, Florida. It failed in Austin, Texas for the police department. Maybe an officer killed himself over it, we're not sure. And now it's up in, the federal government is wrestling with it. Every once in a while it appears on the news again and making fresh promises about, oh, it was going to be done by October 31st, and now it's going to be done by January, and now it's going to be, you know, the usual thing, right? And I think also the Vancouver School Board is starting to use it, and they're having problems too, right? You know, so I don't know. It seems like you know, what can you say? So why is it going so wrong? I mean, is this just a hugely complex, I mean, is enterprise ERP systems, I think it's really complicated. Or, you know, is this always going to be something that's going to be a disaster? Are we going to not be able to pay people in the 22nd century? Are they still going to have people who can't get a right paycheck? I mean, when's it going to end? When is things going to straighten out? How is it going to straighten out? Okay, are we moving towards a solution anyway? Are we, you know, other technologies are advancing. Look at self-driving cars. In March 2004, nobody could finish, no entrant into a competition by DARPA could finish a 150-mile course. 0. The next year, 5 cars finished. Now we have them on the road and we're starting to license, you know, in various jurisdictions. Okay, virtual reality, augmented reality. That was crap in around the 2000. I mean, you know, now it's starting to become real. These are all technologies that are improving. ERP? No. No real advance. We haven't really changed anything in 30, 40 years. Okay? Surveys are still showing high failure rates, significant overruns. This is the Paragon Consulting report for 4 years, 10 to 14. And you notice the less than 50% of the value, percent of cost overruns, almost all of them. Now remember, this is self-reported data. Okay? When they do these surveys, how do they know if a system's a failure? Well, they have to go and ask, you know, make a survey of the people, and people aren't necessarily so keen on saying it's a failure. So probably it's biased down low, right, as opposed to being high. So average duration of an ERP, we're talking over a year, massive overruns in cost, and a high failure rate. But look here, this is a Standish report done in the 90s. It's about the same. High failure rates, right? A lot of systems are kind of nobody's sure they're really successful or not. But, so that's what? That's 20 years. Nothing's changed. Now I can say from my own experience, there was less surveys and that before, but frankly, all the systems I saw around town here being done by people, same stuff. Back in the 80s, the 70s, nothing's changed. Right, the systems are still going on and on for way longer than they should. They're still having massive failures, right? And then, you know, and nothing's changed since then. So that's all the way from 1970 to 2016, right? Which is, you know, 46 years. So I don't think doesn't look like anything's going to really move. Okay, are there any silver bullets? Okay, well, people talk about the cloud. The cloud. Well, what is the cloud? There's the IaaS part of the cloud, right? Which is infrastructure. Very useful. I mean, why would you want to run your own data center? You know, I can whistle up computers all over the world. They're all, this physical security is totally taken care of with armed guards and 24-hour TV, it's all that expensive stuff. And they have, you know, duplicate non-interruptible power supplies, duplicate internet connections, high speed, you know, that's all handled for you. So it's great. Right? Not really a change, that part of it. I mean, there's not much difference in having a computer in the cloud and a computer in your data center, just as more convenient, cheaper, and things like that. It's not going to really change your software any it's not, software is still working on a computer or a client server or something. The other part of the cloud is the web-based. Okay, when you get things like Salesforce or that, you're working through a browser to integrate to some SaaS application in the cloud, right? Frankly, I don't think that's a magic bullet. I think web-based, browser-based software is highly unreliable. I mean, the browser is just a cesspit of insecurity, right? I mean, cross-tab scripting and all kinds of things. So, and the fact is that people trying to support browser-based software have an incredible problem because they're having to work with 5 major browsers, all of which have different ways of doing things. I mean, how do so many random things happen because you don't know what settings the person's put in their browser, you don't know what other things they're accessing in their browser, other kind of JavaScript that may be doing bad things to other things in the browser. So I don't think the cloud is going to really bring anything to the table. New programming languages, well, a lot of new programming languages. We've got you can recite programming languages that are coming along. Python, F#, Go, Erlang, Haskell. Go on and on. Swift, JavaScript. There's various versions and that kind of thing. They don't really bring anything to it, right? They don't make anything easier. They're programming languages. They're decent. Okay, nothing wrong with them, but the functional languages are interesting. We'll talk about that a bit later. Functional languages like Erlang, Haskell, F#, and those they have some interest. Methodologies. What is there a magic bullet in methodologies? Not really. I mean, what's the latest one? Agile. Okay. Well, wait a second. Agile is just really splitting. It's like all religions. Methodologies are like religions. Nobody really has any proof they actually do anything, but they seem okay. But then they always split. Like in Agile, what we got? Agile started off, and now we've got extreme programming, lean development, dynamic system display methods, Scrum, Kanban, feature-driven design, test-driven, and crystal methods. Those are all Agile variants, right? So they split out. Dave Thomas, one of the signers of the Agile Manifesto, has basically said it's just a bunch of snake oil that people use to sell companies for lots of money. He's given up on the thing, right? Because it had nice intentions when it starts. Now, methodologies aren't terrible, right? They do at least make people do things a bit systematically, which is never bad in software. If you can force people to be a little bit more systematic, you can get better results. Unfortunately, with methodologies, they tend to be enthusiasm things. People get already turned on by methodologies. This is going to solve the problem, and that's good because they're enthusiastic. They put a lot of energy in, but then it dies out, and then it doesn't really help anymore, right? So I've been thinking about these problems all my career. I mean, I've written every possible technology probably, and systems. I mean, I've used VB relational databases. I've used multi-valued enterprise systems. I've used index sequential file systems for databases. I've written in MySQL kind of web-based things. I've written, you name it, done it. They were all tough. They were all death marches, right? I mean, you get into a project and you've got some deadline, and then you just get flogged, right? It always seemed harder than it should be. Whenever I started, I thought, well, this is just a system that does payroll or time billing or whatever. And conceptually, it seems straightforward. Yet, as you get into it, the details start hammering you all the time. Everything seems to take longer than it should. Everything takes you down paths you didn't expect to go down. Okay. So, is the problem really, really hard? Or you got the right people? Is it the people's fault? We don't have the right, or is it the tool set? What's going on here? Well, the problem is hard. I've written aerospace software on synthetic aperture radar signal processing, right? It was easier than enterprise software. I mean, aerospace software is easier. Why? Because it's based on physics. Who wants physics? A bunch of equations. Equations are easy in computers, right? I mean, it's easy to implement an equation. I mean, it's complicated, but straightforward. And there was something about the scientific programming is always one case. You're going to send a mission to Mars. Well, you do the calculation, right? And it's all, that's it. The enterprise systems pump out the output of one into the input of the next. Every period, for example, pumps out output from one period into the next period. That seems to throw a lot of problems. Plus, you're chasing a moving target. Every enterprise you're writing a system for is changing as you speak, kind of thing, right? And that's a real pain. And now, the real problem is if you've got 16-month implementation times, well, the chances are very good that by the time you get the system in there, that the company has moved on a lot. And now you're going to have to play catch up in some way, or given the system that doesn't really satisfy them as much anymore. And that's saying, and you know, we've got the right people. I think the right people. I see no reason why the people aren't the right people. They seem to be bright, smart people. They're enthused. You know, I mean, how can you do much better, right? What do? You go and find some new people. Where are you going to get them from? Now, some people think, okay, well, wait a second, Google and you know, Facebook and all those guys get the best people, and the enterprise gets, you know. Well, I've worked a lot with those people. I've had a lot of programmers work for me who went off to Google and Facebook and all kinds of places. I've had also people work for me who's gone off to IBM and enterprise kind of places. A lot of those people that work kind of in those, you know, areas like voice recognition and those kind of things, you know, they think they know everything about programming, but if they ever come and hit enterprise programming, they're stunned by how difficult it is, that they can't, you know, they're nailed to it, right? So I don't really think the people thing is, the tool set, now there to me is probably where we lie, right? Where the issues lie in the tool set. Okay, the problem is hard, but, so if you've got a hard problem, you've got to have the right tool set. If you have the wrong tool set, you know, you're not going to do it. You know, if your only tool is a stone axe, you're not going to make French provincial furniture, right? It isn't going to happen. So it's hard not to get down on yourself. I mean, there's a lot of scolding that goes on in software and systems. You're meant to do everything right. You've got to document everything. You've got to comment everything. You've got to do this. You've got to do that, right? You know, that's tough to do, especially when the deadline's on you and people are demanding results quickly. People tend to take shortcuts. That's just the way we humans are, right? And that's just inevitable. And so you can scold people all you want about not doing the right methodologies, not really, you know, keeping everything in line and all that, but systems just tend to frame the disorder. I mean, it's, you know, there's a law, Lehman's law of software development, that says that, right? So, okay, we've talked a lot about, I've talked a lot about here about all the problems. So, did anyone ever do this properly? I mean, this is a problem that's, you know, did people ever pay people correctly? Well, I think so, right? I mean, let's look back at the paper era. Okay, now the paper era is interesting. This is when humans are the computing elements, right? Paper is the data storage medium. Okay, this has been going on for thousands of years. Maybe they used clay tablets at one point, but same thing, right? Marks on a two-dimensional surface is the storage medium. Okay, this really hit its zenith in the 30s and 40s, and maybe even the 50s, but at that point, computers were starting to come in and take over, right? Now, how do IT people see the past? They basically say small, slow, primitive, right? You know, they didn't do much, and they did it very slowly, and, you know, it was all primitive stuff. Because I was there when we were taking over these systems, when we were writing systems in companies that were moving into computers, and we had no respect for the past, right? They have nothing to teach us, right? Which is always a dangerous thing. You should never think that the past doesn't have something to teach you, right? They handled really huge data. This is 1904. This is the Metropolitan Life Insurance Company in New York City. They handled $400 million worth of insurance in 1904 dollars, which is about equivalent to $8 billion in today's dollars, right? Millions of claims, right? And they did it all on paper. Now, a lot of people talk about, well, okay, it's easy with people though. I mean, they had it easy, right? They didn't have it like us. We were programming computers, which was really hard and complex and technical. They just had people. People are easy to instruct. They got common sense. They can respond to unexpected situations. I mean, how hard can it be? Well, look at that. Those people, you don't want them to work in their common sense. I mean, when you have people like that, you want them all to be doing the mechanical operation exactly as you've told them. You don't want anyone screwing around with anything, making up their own mind about anything, right? I mean, there's like 500 people in that room if you count, and they're all going to be working, processing in some systematic way. So this is interesting. Those people are sitting down. They're not standing, by the way. They're at stations. And this is a way you could, for example, one thing you could do here is how you solve the problem. You've got sales orders coming down. You're selling inventory, so you want to keep your inventory up, right? So you've got a sales order for an inventory item, but you can't have everybody just go and take a sales order and then go looking for the right cards to update, because there'd be huge queues for a popular card, right? So you do it this way. Everybody has a set of inventory items that they're in charge of, and the paper flows through, and you update your ones and then move it on to the next station. Now you're part of a machine here. Like, this is none of this getting to work and picking up a latte, right, and wandering in late. This is like 9 o'clock in the morning, everybody has to be there, because this machine doesn't work unless everybody's there. If somebody's missing, papers start piling up at one station, right? So this is like, these people, think about that job. They take this form, they pick a form up. Okay, I got that item, right up. Okay, cross that one, I'm done, put them on. Next day after day after day after day, right? 9 to noon, 1 to 5, 2 coffee breaks. Everybody regimented, because you're part of a machine, right? You can't just wander off for a break. The whole thing breaks down. So very mechanical. These people were programmed. Okay? So they solved the same problems. They had resource problems that we have to solve in computers with, we do threading in computer systems and have, resource queues and systems and that. And they had the same thing with people. So they had to design these systems so they didn't get kind of, things all bottling up at some point and all that. It's quite difficult. They had to synchronize resources. They had to do indexing, right? I mean, if you have look up, if you have a name come in, you've got an insurance claim, you don't know the number, well, you have to have an alphabetic to number index in your index card, so you can look up John Smith and say, oh, he's claim number 154, and then go and find it. That kind of thing, right? They did all that, same as we do. So, why was it easy for them to do this? That's an interesting question. Okay, what is it about human computing that makes it easy? Because it's clearly not their magical human ability to respond to change and all that kind of thing. Because these people are working like machines. We could probably write a computer program to do their job. If it could fit it in somewhere. So these, after I looked at it for a while, these are the kind of key factors, I think, that make it easy, right? That were things that we've overlooked in our modern age, which really they were using. And this is as of, context, verifiability, and common business knowledge. So let's look at as of. As of processing is so natural for humans. Starting Monday, I want you to get up an hour earlier. Okay? That's not a complicated instruction. You give it to your kid, right? Monday, you've got to start, school's Monday, right? As of Monday, you've got to get up an hour early. As of, I'm in business, they would go to the accounts receivable department. As of the start of the month, you want to start giving people a discount. Okay, people have no trouble with those kind of instructions, right? If the accounts receivable manager gets in a couple of invoices, and one is December, one is January, processes the December one like a December, processes the January one like it's a January one with a new discount or whatever the change is, whatever the business logic is, right? So, and this solves the code upgrade trap and the data upgrade trap we're talking about. So humans have no trouble with as of. But our ERP systems are kind of like single snapshots of business logic, right? They're one set of business logic. Now there's a few variants you can make. You can make some tables date dependent, like a percentage maybe changes or something like that. But fundamentally, they're one set of business logic. And what you have to do is you have a problem. Let's suppose we customize the ERP system, and then they bring a new version. What do you do with our customization? You've got to reapply them. Are they going to work with the new version? Maybe, maybe not. Right? They're going to be a problem. It could be as hard to apply your customization to the new version as it was to apply it to the original version. It takes a lot, it takes a lot of work. That's the code update trap. Well, Agile programming solves that, because they didn't have that problem back in the paper era, because what they did was they had Agile programming. So they would, change their business logic as of a certain date. Now the data update trap, when I was once working with BC Hydro, and they had a system, and then the start of the new year, they wanted to change the business logic fairly materially. But that meant, of course, ERP systems and with databases, quite often they do a significant change in business logic. You're going to change the data model. And that usually means, if it's a serious enough change, you've got to offload all the data and transform it into the new data model. So you get a new system, new code. So what they did was they waited at the end of the year, they got all the transactions through, and then they converted it all to the new system and ran the new system, the new code. But the problem was it was late coming in transactions, because there's the auditors' adjustments always coming late, and there's always stuff that just doesn't make it, right? It's just the nature of the beast. So they had to put those into the old system so they could run their year-end results, and they had to put them in the new system, right? But the new system treated them differently. So their opening balance didn't agree with their closing balance. Well, that's a major disaster for a large corporation, right? So they, it took them weeks and weeks and weeks to get all that, that's a data update trap. Can you really make the change to the model and, and keep it going? Now, context. Now, this is another really interesting one. It's my favorite, actually. Context is another aspect that humans take for granted, right? Business runs on context, but we don't really recognize it. Okay, it's part of the most powerful, overlooked aspect of business. Let's suppose we're having a meeting here, and we're going through all the employees in our company, right? So I'm picking them up, and I say, oh, okay, Mary Smith. How many timesheets? And Lyle over there says 6. What does he mean? Well, he means that Mary has 6 timesheets, right? Nothing obvious about that. Nothing unobvious about that. That's context. We were in the context of Mary Smith, right? So the question of, let's see the timesheets, how many timesheets, all that kind of thing, is answered, right? You can go get it. You never in business step outside context, almost very rarely. There's always a context you're working in. We're talking about a department. We want the balance sheet. Well, you want the balance sheet for the department, right? If you go to the company level, you want the balance sheet. You want the balance sheet for the company. It's everything in business is done in context. Now, take a look at this. This is a rate table. Let's suppose we're back in the paper era. Okay? Well, this is a very small one. It'd be bigger than this, but just a sample I couldn't get on the slide. But so you've got that posted on a wall, right? Actually, those rates are way too high for the paper era. A senior engineer would be getting like an $8 an hour charge out of 10 bucks. I looked at the rates one time. It's kind of scary, right? But anyhow, those are more like our rates. Okay, then a clerk comes along, is processing a timesheet from Mr. or Ms. McKenzie here, and there's a line on the timesheet that says Project 500 is charged 12.6 hours. Okay, well, what's the fee? Okay, well, the clerk, quite naturally, says, fine, okay, I've got Mackenzie. Mackenzie's a senior engineer, and Project 500 is a government job, so he's going to get $120 an hour, right? For 12.6 hours, which is $1,520 or something like that, whatever. Okay, so that's all done by context, right? The context is Mr. McKenzie. Therefore, as soon as you had the context, it resolved the position. As soon as you had the project, it resolved the type of project it was. It was a government project, right? And so that's the rate you get. And that's very powerful. When you think about it, what we do with joins and relational databases is way, way more cumbersome. So contextually aware software makes it easy. So I'll show you here. Okay, this is part of Formever, the software. So I wrote Formever order to accomplish all of these things, right? So here's an example of context. See here, I'm on a timesheet detail line, and I'm going to make a definition here, and I'm going to define what fee amount is. Okay? And it's a multiplication. Take the adjusted fee hours. The adjusted fee hours are another definition because, you know, the person's entered the hours on the line, but maybe then you have a supervisor adjust them. So, you know, if they're, you know, maybe, so that's the adjusted hours of what you're actually going to bill for, as opposed to the raw hours which you're going to base cost on, right? You know, but, and then you say, okay, what am I going to multiply it by? And you get a choice here, and it offers you sub-project because there's a sub-project mentioned on this detail line. You're charging this project 500 so much money, right? So you click on sub-project, and it shows you the rate table. Every project has a rate table, okay? Now you click on the rate table. Now, for every rate table in this system, there's a bunch of rates for one rate for every employee. So normally you're stuck here, right? Because you got the rate table, but now you've got 50 different rates, one for every employee. But the system is smart enough, and that's why it's in purple there, to say, no, wait a second, you're in a timesheet. This timesheet is for a certain employee. So clearly you only need that one in the rate table, right? Boom, you pick that, and then you pick rate off it, and you're done. And then you can do a report like this, and you can see here, is there a pointer on this thing?
I think so.
You can see here that, you know, we have hours, and here's the fee, which is that multiplication, right? So you don't have to do anything more. You can just treat this fill, just dump on a report now. And this report is done with context because when you say, okay, I want to go through all the projects, right? Every time you get to a project, you say, give me all the timesheet details. List out. These are all the details from, you know, here's all the lines on timesheets, this person for this project, these different people, EDW is the guy, I guess, the person. So that's context too, right? You don't have to do a join, you just say project, give me the timesheets. Surely the system should know which timesheets you mean. I mean, we're working with that guy's timesheet, you know, working with this employee, working with that project, so you want all the timesheet details that reference that project. You don't want the ones that don't reference the project, reference a different project. That's kind of stupid, right? I mean, you just want, it's common sense, you just want the ones that reference that project. So you shouldn't have to say anything extra to get that. You just say it and get it, right? And that, you know. Now, I grabbed a triple join out of, I tried to do that same calculation with the rate tables in SQL. My brain fell out. There's 6 tables involved, right? You've got the employee table, the timesheet table, the timesheet detail line, so it's normalized, so you have to have a detail lines in a separate table, right? And then you have the project table, you have the rate code table, and then because it's normalized, you have the rate code, the rate cards, one for every employee, different rate, right? So there's 6 relational tables that you've got to merge. I don't know, a 6-way join is beyond me, right? I mean, frankly, I've never been that comfortable with all these very complex SQL statements, right? Because they're just difficult to debug and write. And frankly, this is a kind of sample of a triple join. This is not, but I couldn't do the 6-way join. I couldn't figure it out how to say it. When I write for a relational database, I usually give up. I mean, I do what most programs do, all the ones I've seen do. You just go and you get the stuff. So you say, okay, give me the project, and then I pick this off, and then give me that stuff, and I'll pick that off, and give me that. And just write it in code, right? Rather than trying to put one SQL statement that somehow does all the joins and groupings and comes up with what you want, which is really, really hard to do, right? So, you know, so why I mention that is when you compare this kind of thing to just going click, click, click on selecting the rate when it's in context done, it's like to do that code that did that same thing in relational database terms, I would say it's a day work, right? And to get onto a report. And I know if I say it's a day, it's probably going to take me 3. Something will screw me up somewhere, right? Whereas I do it that way, it's like 30 seconds. So you can see there can be massive increases in productivity if you can kind of, get the logic working right. Now, the next thing is verifiability. Okay. In the paper era, we could verify stuff. Right? We could follow it. So let's say the Phoenix, you've got the payroll problem. It's not running the right amount. Okay? And here you are, the check is wrong. The guy owed more money than that one. So you walk it back. And that day, you just go to station, as the forms, the timesheets came in, they were extended and all that, and then put the ledgers and moved on to the next and next and next. You'd follow all that through. At some point, there's an error. Or it's the right number, but if you don't, if there's a number that the payroll run is wrong, somebody's made a mistake somewhere, right? And then you trace it and find it. Now, they don't seem to be able to do this in the Phoenix system. They don't seem to be able to, you'd think, I would think, anyhow, if writing a system like that, you'd be able to put in the SIN number, and it would give you a logic tree of exactly how it was computed. That would certainly solve your problem, right, of why is it wrong. Right now, they don't seem to know why things are wrong, right? They can't tell. So that means that, they really don't have any kind of verifiability in their system. So what's the computer technology equivalent of verifiability? Is logic tracing. Think of an Excel spreadsheet. In an Excel spreadsheet, you have a cell, it doesn't have a number in it, has a formula. A3 plus B9, something like that, right? A3 is probably another formula, could be something else. You could write a VBA macro that would actually follow that through and tell you exactly how that cell was calculated, right? I don't know if people in Excel tend to do that much. There probably maybe easier ways, but you could, right? So Excel is kind of a functional language. Functional languages these days do tend to be a bit better at logic tracing, although it's not guaranteed. So, the most of the ERP systems are written in proprietary languages, right? SAP is mostly ABAP. PeopleSoft is People Code, and then we have all the Microsoft Dynamics family. I don't know if you're familiar with Microsoft Dynamics a lot, but Microsoft went and bought a whole bunch of companies, right? They bought Navision, Great Plains, AX, I forget what that stands for, C5, and they have their CRM offering. They're all in different languages. Most of those are proprietary. Dexterity, CA/AL, right? But most of these are object-oriented languages, low-level languages, basically. Not application level, anyhow. What's low-level meaning languages? But these are really general-purpose computer languages. You can probably do a lot of them, but isn't necessary. Now, the other thing is common business knowledge. This is a lesson thing that when you're talking to humans, they understand certain basic things, units. You can say to a human, hey, add all that up in meters and convert it to feet. What's so hard about that, right? But we don't seem to have this. They also have locations, they understand where things are, but we do in computer systems pretty well too. That's not a problem in computer systems. Knowing where to put data is not usually a problem, right? Arithmetic, well, it's not usually a problem in computers either, maybe, except extracting data and reformatting it, which is kind of done by computers. But even today, most databases have no currency type. SQL Server has a money type, right? But Oracle doesn't, it has a number type, which is kind of fixed decimal. ABAP for SAP has a packed decimal in its language. Most of the languages don't have these types. Like numbers and units and all that have very specific characteristics. It can be very easy to use if the system does it for you. If you're forced to go and try and express this in a floating point number or a packed decimal number, and then you have to handle all the units yourself, or you have to handle precision and round off and all that, it kind of just takes a lot of work that really you shouldn't have to do. It's putting a lot of burden on the implementer, right, as opposed to the code. And that's one of the problems. I don't really know why this has happened. SQL Server putting money in seemed to me that's really obvious. They should have done that like 20 years ago, and all these other people have done it too. And Java today doesn't have a decent money type in it as a language. I mean, it has, some various data types, long decimal, long integer, and that, and it has big integer, which is giant, but it doesn't really help you when you do business processing. There's not a lot of support for business processing in these languages. Because everybody's trying to cover the widest domain they can. I mean, you've got a database like SQL Server, you want to allow the geologists to use it as much as the accountants, right? And so, of course, you're not really wanting to specialize it, because that's going to cut your market share, which is okay for Microsoft, but not so good for people trying to do business applications. The simple forms, now, all the paper era worked on paper forms. Paper forms are pretty simple, right? What can you do in a paper form? You have fields, you can have a list, right? You have a couple of lists if you really want, but that's about it, right? You don't have tabs, you don't like some big, UI where you have tabs and things and all that kind of stuff. I talked to a person when I was using Blackboard, Razor's Edge, which is a package for not-for-profits, started with universities fundraising. They don't call it fundraising anymore, right? They call it development. Much nicer sound. Fundraising sounds too. But they weren't using hardly any of it. So Blackboard, Razor's Edge, has this big UI element with 13 tabs, and every tab has a massive number of fields with a few different variants. It's hugely complicated, right? And this person I talked to, they only used about one thing, right? And most of the terminology wasn't for them. It was all about universities and alumni and things like that. And they're a hospital charity, a foundation that runs a hospital, collects money for a hospital. So the simple forms, though, I mean, they supported the whole of the economy back in the day, right? Huge companies like General Motors back in the 30s were done on that. So it's perfectly possible to go with simple forms, and people understand them. If you throw out all these complicated UI elements, do people really understand it now? Now you've got all these choices in that, and they don't really know what they're doing. Right? Plus, if you throw a lot of extra columns and things they don't use in there, that greatly even increases it. And what you've done is really increase the chance of error. Right? So what you want is the minimal viable system. So modern manufacturing is additive. 3D printing, right? Build it up. Right? As opposed to subtractive, which you take a block and carve it into whatever you want. Right? Throw away everything you don't need. Okay? But, I think ERP needs to go that way. Okay? You want to build exactly what you need. If you take a big ERP system and say, oh, I gotta make this work for this company, that's a massive job. It's also far more difficult than people understand. I mean, probably the reason the payroll system, the Phoenix system went wrong is they had a system that was working for companies and they kind of applied it to the Canadian government, which is pretty much a unique animal, right? I mean, they do things differently in government than they do in enterprises. I mean, it's just a different environment. And taking one system, it's never guaranteed. I mean, people tend to judge systems by their functionality. Right? It's a payroll system. It's a time billing system. Therefore, we can make it work for somebody else's payroll or time billing. The trouble is, this is kind of a trap. It may work. This is why we have, I believe, and one reason we have inconsistent outcomes with these systems. Sometimes it works, and you can actually take the system and change a few things and make it work for that company. Other times, it seems to just go down the rabbit hole, right? And why is that? It's because just because it's payroll doesn't mean to say what the architecture underneath is. If you find out when you open it that they've constructed things in certain hierarchies that you have to reinvert them and things like that, you can have a world of hurt open up to you, right? All these assumptions throughout the code will have to be changed, and the whole thing becomes highly unstable. So it's never a good idea to look at a system like an ERP system and say, well, it does this, therefore I can make it do it for that company. You may be opening up something that is going to bite you really badly. On the other hand, it may work. So it's of course, salespeople unfortunately don't tend to discriminate so much, right? They just want to get the sell. So, So, putting it all together, the enterprise software needs to be as of, context aware, verifiable. It should handle all the basic business knowledge, forms, units, sorting, selecting, all that kind of thing. Use simple forms, be straightforward so people understand it, and be additive, be built up into a system that does exactly what. There should never be in a system a button, a control, or anything like that that isn't needed by that company. If it's not needed, take it out. I'm never sure why people do this. They put these systems in, and like that Blackboard one, and they have all these features. Is it hard to take these features out? I mean, menu choices, sure, you can just turn them off. It's not, but nobody seems to want to do that, I guess. I'm not sure why. I guess maybe, they're too embedded in, or it's too hard, or something like that. So you just throw it in there. I was at a company in Annacis Island doing some specialty wood processing machines they were a distributor for, something like that. And basically what they did, they were using a Navision, and they had all these screens with masses of columns that they didn't use. They would scroll horizontally like this. And then, of course, the inevitable happened that some summer worker or temporary replacement came in, didn't really know, went into some screen that they don't use, made some change, and it took them weeks to clean it all up and get back again, right? Why? Well, they should never been able to go there, right? If they didn't use those columns, they should have just been eliminated. Usually in computers, it's not hard to eliminate things off the screen. It's not, it shouldn't be, but, So I wrote forever to incorporate those lessons. I just, I got tired of doing the same stuff again and again and again. Every time I did a time billing system, I had to write some kind of fee calculation, and then I thought, I've done this before. I don't know how many time billing systems I've written in my career, 5, 6, 7, I can't remember, right? A lot of them. But, every time I did it, I felt I was just doing it all, same, different language perhaps, different database, different computers, more sparkly operating systems, faster computers. Doesn't really make much difference though, right? I mean, it's still the same kind of grind through the logic. And so I decided that I wanted to make a point-and-click language. I had to figure out how to do that so that the choices are proved. So when we saw that, rate calculation, there. Yeah, when we're doing this, when you're in an expression like a multiply, it offers you the rate, right? Well, it wouldn't offer that rate if that rate was dollars. That rate is dollars per hour. So you can multiply it by hours, right? I mean, we should keep, in computer systems, we should respect dimensionality. And you can't multiply dollars by dollars, right? That doesn't make any sense at all. Dollars by dollars is dollars squared, right? Which has really no meaning. Okay, hours times dollars per hour. Absolutely, right? Makes perfect sense. So the system will only offer you the things that make sense. So that kind of avoids a whole bunch of problems, right? That. So, I don't think the existing tool set's going to happen. I mean, I'm not saying it's going away. Absolutely not, right? This is not going to happen. There's a huge amount of, ERP is rolling along. It's very, very profitable. IBM in this Phoenix system is getting paid extra money to work in the evenings, so to try and fix the system. So they're paying an extra 5 million or 10 million, something like that, right? I mean, failure is very profitable. Okay, this turned out to be in ERP systems generally. It's very, very profitable. In fact, the more complex a system is, the longer it takes, the more expensive it is, right? So, I mean, especially if you're charging $200 an hour, you can basically evaluate how bad a language is by the dollar per hour rate of the consultants. If it, because like I wouldn't work in ABAP. I mean, you couldn't pay me. I mean, well, maybe pay me $500 an hour. I might think about it, right, or $1,000 an hour. But like for most people, it's just like, do I really want to handle this stuff? It's just crappy. right? So when you get really bad environments and also have a long, fairly large learning curve, right? Then the hour, and if it's a bad environment, the learning curve is really high, right? Because it's tough to get into some of those things. So the rate goes up. So when you look at these really high rates, you can pretty well say, well, those are a tough system to work with. They're going to be high. Plus, so the work needed is just too much. 16 months to do an ERP system, I think is ridiculous. It used to be a year, or I don't know. There's been changing. I don't know what the studies say. It's been bumping all over the place. It's hard to know what it really is, but it's certainly over a year. It's probably closer to 2 years these days, right? Somewhere in there. Nobody's going to blink if you say, "Well, it's going to take us 2 years." It doesn't seem like that's really a showstopper, right? And that's an incredibly long time to try and track a company, right? And keep up with it. So now, what's going to happen? Well, I think at some point we're going to have to pay people properly and not put them in jail when they don't deserve to be there, right? It just seems that we can't go on doing that kind of stuff forever. The drumbeat of all these newspaper stories about all these failed systems and everything. Look here in BC, we've had several papers. I don't know if you guys read all these, but all the time they're happening, right? 180 million, the last one with BC government. The Vancouver School Board it's costing $850,000 a year to pay 3,000 people. I think you could actually probably pay people to do it by hand cheaper. It's just going on like that. So, however, is it likely to change quickly? No, I don't think so. I think it will, and I think the place to go is into the small, medium businesses. The large businesses probably aren't they're going to remain very conservative and go along with the name brands. They always used to say nobody got fired for hiring IBM. Maybe that's still true. But the small businesses, like 30 people to 500 people, then I think that's probably where things have to change. They're getting really hammered. I've seen people that, I was looking at a company some time ago, OceanWorks, that does deep sea submersibles and things like that, and they were trying to put in an ERP system, and they were talking to different vendors, and they got it's going to cost $1 million. I think they were looking at Vision. They looked at a couple of others too. They were running on Ban at the time. I don't know if you're familiar with Ban. It's a fairly old one, I think. So
I was on Ban when I first
there you go. Well, they were. I think they're. I don't know. In the end, they couldn't afford the price, right? It's more common in small, medium businesses that they just can't afford that kind of money, right? In the big enterprises, the money's a little bit more available. So, are they going to push back against all this? I don't know. I think eventually I would like to think that the kind of approach that I'm proposing here is the way to go. Is to cut down get the right tools, cut down implementation times, and make the systems easier to use. So I think that's going to happen. But like all future predictions, the hardest thing to do is predict timing. How long is this going to take? I can't believe in the 22nd century we're going to have all these failures. And my whole being rebels against that. My whole sense of optimism, right? You can't have a Phoenix system or the Odyssey system putting people in jail in the 22nd century. Surely we've advanced beyond that. And we look back at this time and say, what the hell was going on? What were we doing? Why was that all? Why were these people all just getting abused by these systems? But how long? I don't know. So